Good morning, student. Let's start our new chapter, that is the nitric acid. In this chapter we will learn about the preparation of the nitric acid, then property of the nitric acid, and physical property, chemical property, both property we will learn, and use of the nitric acid. And this chapter is very important. Some reaction are very important. I will tell you which type of question asked from this chapter when the particular topic is covered. Afterward I will tell you. Okay, so let's start this chapter. So first, that is the introduction. In introduction, what is first, that HNO3, that is the formula of the nitric acid, and it is a strong acid and it is a colorless liquid. Okay, that is the first thing. In the earlier time, nitric acid, when discovered, at that time it is known as aqua fortis. Why it is aqua fortis? Because what is the meaning of aqua fortis? First, the meaning of aqua fortis, which means the strong water, aqua which means water, and fortis which means strong. So the aqua fortis, at that time it is known. Why it is known as a strong water? Because at that time only this liquid, which means nitric acid, can be able to dissolve silver, to bifurcate or to separate out the gold and silver. To separate out a gold and silver, this method is used. So the nitric acid is can able to dissolve a silver. So through that gold and silver we can separate out. So that's why it is known as a strong water or aqua fortis. Okay. Now afterward, in who discovered first time this nitric acid? So the in 6050, the Gullberg prepared nitric acid by reacting with the potassium nitrate with concentrated H2SO4. So the potassium nitrate which is known as distilled nitrate also, this potassium nitrate also known distilling nitrate with concentrated H2SO4 when react, and particular at that time the aqua fortis discovered. Okay, and afterward in 76, one of the scientists, the Lavoisier, proved that the oxygen is one of the constituent particle or one of the constituent element present in it. So the Lavoisier, when the Gullberg discovered that particular this liquid, he don't know the name of this compound, he don't know the formula of that compound. So he just give a name, that aqua fortis. But the Lavoisier discovered that one of the element present in this aqua fortis, which is oxygen. And after the afterward, then in 1784, the Henry Cavendish proved that a nitrogen and a hydrogen also present in it. So this is the way it discovered that it is the particular liquid which have a hydrogen, nitrogen and oxygen. Okay, I hope you understand this introduction. Now the next, let's see the next one, that is the occurrence. So there are two ways the nitric acid is present. So first is the free state. In a free state, which means that only the nitric acid present. So in atmosphere, first and most important, it is present in atmosphere. In air, a little bit amount of nitric acid is present. Through the pollutant, it is present into the atmosphere, or through this nitrogen. This is the, by this reaction also, by this reaction way also the nitric acid present into the atmosphere. What the reaction it is? The first, the nitrogen present in atmosphere. So then nitrogen, through the lightning, when the lightning happening, the very high energy will be produced at when the lightning will happen. So at that time the oxygen which is present into the atmosphere, nitrogen also which is present into the atmosphere, both react together and convert into the nitrogen oxide, NO. When this nitrogen oxide further react with the oxygen which is also present into the atmosphere, it convert into the nitrogen dioxide, NO2. Okay, and this NO2 present, this NO2 react with the water, which means the atmospheric moisture. In atmosphere, moisture is present. So when it react with the atmospheric moisture in presence of oxygen, it convert into the nitric acid. So this is the way. There are three steps, first, second and third. First, the nitrogen react with the oxygen, convert into the nitrogen monoxide, and this nitrogen monoxide react with the oxygen into the atmosphere. This whole the reaction is happening into the atmosphere. Okay, very fast, because during this lightning, this first nitrogen monoxide will be produced, and this nitrogen monoxide is not a stable compound. It immediately react with the another compound. So that's why it react with the oxygen and convert into the nitrogen dioxide. and this nitrogen dioxide is able to dissolve into the water. So it immediately dissolve into the water which is present into the atmosphere by moisture state. So it react and convert into the nitric acid. So this is the way it is present in a free state. And during the rain, this nitric acid is can come down into the soil. So when through the rain, this nitric acid is react with the soil. So in soil there are so many components like calcium carbonate, magnesium carbonate, so many components are present into the soil. So in a soil, when this nitric acid is react with the calcium carbonate which is present into the soil, it convert into the calcium nitrate and water and carbon dioxide. Same the magnesium nitrate also present in atmosphere. So through the magnesium nitrate it is present into the atmosphere and convert into the magnesium carbonate present into the soil and react with the nitric acid which is coming through the acid rain and convert into the magnesium nitrate. So that is both this compound, both this nitrogenous compound, we can say both are the nitrogenous compound are useful. Both the nitrogenous compound are useful. If it is in limited amount, then it is useful. If it is more than required amount, then it is harmful for the soil. It can destroy the fertility of the soil. So if it is present in the limited amount of the amount into the soil, then the soil become fertile. So that's why these are the useful nitrogenous compound. And the fertilizer, and this fertilizer is called as a fixation of atmospheric nitrogen. What it is called? Fixation of the atmospheric nitrogen. Okay, you underline in your textbook, it is given. It is called a fixation of atmospheric nitrogen. I hope you understand this is the free state of the nitric acid. Okay, so very important, the full reaction is very important. It is present in atmosphere. How atmosphere it will react? Nitrogen react with the oxygen in presence of lightning, convert into the nitrogen monoxide convert into nitrogen dioxide. This nitrogen dioxide dissolve into the atmospheric moisture, convert into the nitric acid, and that nitric acid rain through react with the soil carbonate compound or soil compound. So when it react with the soil compound, it convert into the nitrogenous compound, and that nitrogenous compound is called as a fixation of the atmospheric nitrogen. Fixation of the atmospheric nitrogen. I hope you can able to remember all this reaction, because very important reaction for exam point of view. And this one also, fixation of the atmospheric nitrogen. Okay, you can this complete the reaction in this two reaction may be asked, and this reaction also. Okay, so you tick mark this reaction in your textbook given it is. So now let's do that next point, that is combination state or combined state. So in combined state it is occur as a mineral nitrate, as a mineral nitrate. Very important. These are the common name of the minerals, that is a chili saltpeter, which is a sodium nitrate. This is a sodium nitrate. NaNO3 is a sodium nitrate, which is common, sodium nitrate is a scientific name, but chili saltpeter is called as a common name. Okay. Then the Bengal saltpeter, which means potassium nitrate. It is discovered in Bengal, that's why it is known as a Bengal saltpeter. So that's why it is a Bengal saltpeter potassium nitrate. Then the calcium nitrate. This is the way also the nitric acid present in a mineral nitrates. Okay, so this is a combined state. I hope it is clear. You need to remember all these three with the formulas. You know very well what is the formula of sodium nitrate and potassium nitrate, that through that you can able to write. But if in exam it is asked that what is the formula of chili saltpeter and Bengal saltpeter, then you have to know about this both the formulas. Okay, so for remember you can write bank, which means that a Bengal saltpeter which means K. Okay, and other one, that is a chili saltpeter, you can make it like that also. So chili saltpeter, a bank, that is a Bengal potassium. Now the next, that is laboratory preparation of the nitric acid. Let's see the laboratory preparation. First the reactant, what the reactant are required. So the first through that sodium nitrate or potassium nitrate, you can take any sodium nitrate or potassium nitrate when react with a concentrated H2SO4, react with the concentrated H2SO4, it convert into the nitric acid and the sodium bisulfite and potassium bisulfite, sodium hydrogen sulfate or potassium hydrogen sulfate, that you can say. Now here the temperature, this two thing is required. I will tell you about temperature later. First let's talk about the reactant. So you can take any, that is for any you can take, but here the concentrated H2SO4 we have to. So the why the concentrated H2SO4 is used, why not as another acid like a concentrated HCl. So concentrated HCl also we can take, right, concentrated HCl also we can take, but why we are using this concentrated H2SO4. So the first reason is that concentrated H2SO4 is a non-volatile. So many time I told you, you need to remember this thing, student, very important, that concentrated H2SO4 is a non-volatile and the product will be formed, that is a volatile. HNO3 is a volatile. If you use the volatile substance here, then this product will be not, this product is a volatile. So both the volatile mixed together. So the particular product will be not formed. So that is the first and most important reason for this, that why we are using concentrated H2SO4. That is the first reason. Okay, we can say like this. Also, if we use this HCl, then the product will be formed, and let's see the which product will be formed, that NaNO3 plus HCl if we use, then the product will be formed, that is NaCl plus HNO3. Here HNO3 form, but this HNO3 is a volatile or vapor, it is converted into the vapor, so it is a volatile, and HCl also a volatile. So, and the hydrochloric acid boiling point also a 109 degree, right. So the boiling point, so it will boiled at for particular temperature. If we use the greater than 200 degree centigrade temperature, then it will volatile, it become vapor, so it vaporize. So both are non-volatile, we require non-volatile solution, that's why we are using concentrated H2SO4. That is the first reason. I hope it is clear. Okay, I hope it is clear. So that is the first question. Second question, why the temperature is greater than 200 degree centigrade? Very important. Why we are taking a greater than 200 degree centigrade temperature? Why not a less than 200? So here the first reason, if we took a temperature around a less than 200 degree centigrade, so the what the product will be formed. So let's see. So same product I am taking, a sodium nitrate plus concentrated H2SO4, but temperature is a less than 200 degree centigrade. Temperature if we take greater than 200 degree centigrade, here that less than 200 degree centigrade. So it become 200 like this. If we take like, then it will form here HNO3 plus a sodium sulfate, not sodium bisulfate. Here you can see that sodium bisulfate, and this is the sodium sulfate, and this sodium sulfate is a very, when it is formed, it is present in a solid form, it will convert into the solid form, and it is very hard crust, it is very hard crust, and it will settle down into the apparatus which we are using. So everywhere the sodium sulfate will be settled down. Here the same amount of HNO3 will be produced, same way HNO3 will be produced, but what is the reason here, if we are using the more temperature, if greater than 200 degree centigrade if we are using, then it will convert into the sodium sulfate, not sodium bisulfate, and sodium sulfate is in solid form and very hard white color, very hard solid substance will be produced, and we are doing this in laboratory, so all the apparatus become white in color and we can not able to find out sodium nitric acid properly and clearly. So it will settle down and it will break our apparatus, and so many things will happen. Okay, so another, the second reason, if we use a more temperature, more than 200 degrees centigrade temperature if we use, then at a very high temperature a nitric acid decomposed. This nitric acid, when the nitric acid will be formed, the temperature, if a temperature is more than 200 degrees centigrade, then it decomposes into the nitrogen dioxide, water and oxygen. So that is also happening. So instead of if we are making HNO3, so we require HNO3, not NO2. So it's required around 180, it's required around 180 degrees centigrade, not more than that. So it less than 200 degrees centigrade is required, not greater than. So why the temperature is less than 200 degrees centigrade? That is a condition. So this is the reason. If we take a greater than 200 degrees centigrade temperature, then the sodium sulfate will be formed, and which is a very hard crust and settle down. And it is so when the nitric acid will be formed, it decompose into the nitrogen dioxide, water and oxygen. And also if we are getting our main product, then why we are using wasting our fuel? So third reason also we can say the fuel is wasted. So there are three reasons. Okay, this question you need to remember why we are taking the temperature like this. In SCl also we have learned this. So don't mix together SCl and HNO3, both are different thing also. Okay. Now the third question, the why HNO3 is yellow when is prepared. So you know that as at the beginning of this point I told you the HNO3 is a colorless liquid. But when we discovered in this reaction, after this reaction, we found that it is yellow. So why it is yellow in color? So because that when we make reaction, when we are doing this reaction, so this reaction, the HNO3, the temperature at that time the temperature is little bit high, not more than 200 but high it is. So the some amount of the HNO3s will be decomposed, not full, not all the amount of the HNO3, but some amount of the HNO3 will be decomposed, and it form a nitrogen dioxide, H2 and O2, and this nitrogen dioxide is brown in color, reddish brown in color. HNO3, sorry, NO2 powder is a brown, NO2 gas is a brown in color, and this NO2 gas immediately dissolve into the water and make a solution, and that solution brown is little bit diluted, and this solution become yellow in liquid, so yellow in color. Okay, I hope you understand this too. So this is the another question, why the HNO3 is yellow in color when we prepare it. So you can write this, then that at that temperature when the nitric acid will be formed, then it is a little amount of the nitric acid will be decomposed into the nitrogen dioxide gas, water and oxygen, and nitrogen dioxide is a brown in color which dissolve and form a solution, and that solution is a yellow in a color. So that is why we can able that HNO3 that we are producing, in that this solution, little amount of this solution is dissolved in it. So that's why it is a reactive. So see what happening here, the reaction, how the reaction is produced. This is the round bottom flask like this. This is the round bottom flask. Here from this concentrated H2SO4 is added. Here some parts of the sodium nitrate, and here through this H2SO4 is added. Now from this the temperature we are applying. Now this is the bottle, and here this round bottom is put into the ice. This is the ice, and when we heat it, when we heat this solution, this is the mixture of H2SO4, we can say H2SO4 plus NaNO2, NaNO3, sorry, sodium nitrate. So this is the mixture. So in this mixture when we heat it below 200 degrees centigrade temperature, so the vapor will form, and vapor is coming from here, and here you can find out the temperature is less because this beaker is put into the ice. So it condense, and here it is liquid will be formed, and that liquid is yellow in color. that liquid is yellow in color. So why it is yellow in color? Because of this decomposition reaction. Got it? Now how we can remove, how we can decolorize this solution, how we decolorize this solution. So usko for decolorization we collect this solution first and pass the carbon dioxide or the dry air into this solution. So the what happened that when we pass this carbon dioxide or dry air, we pass this carbon dioxide and dry air through this, it dry out the nitrogen, it dry out the nitrogen gas, NO2 gas, it will dry out. So when the NO2 gas will be dry out, then the color become colorless, so color will be reduced. So yellowish color is due to this NO2 gas, yellow color of the HNO3 is due to the NO2 gas. So if we dry out by passing the dry air or a carbon dioxide, so it will it will dry out, and then the yellow color will be disappear and the solution become colorless. Solution become colorless. Or another way also, by adding the water drop by drop. By adding water drop by drop, which means that when you add water in it, so the particular reaction will be formed. That reaction, okay, I'll write here. When you are adding water in it, so NO2 gas present in it, when drop by drop you add water, so the water is immediately react, or nitrogen dioxide immediately react with the water in presence of oxygen, because it is in open atmosphere, so definitely oxygen will be there. So this will be produced, and here the 4HNO3 will be formed. So this is the way also. First, what is the reaction? The carbon dioxide if you are adding, or dry air if you are adding, so and then nitrogen dioxide will be dry out. But another way also you can do, by adding a drop by drop, very slowly, one drop if you are adding in it, so that water is immediately react with the nitrogen dioxide, because nitrogen dioxide is reactive and dissolve into the water. So it convert into the HNO3. So by this way also we can decolorize the yellow color to colorless. I hope it is clear with you, student. I hope that you understand this full thing. So this is the way we will get a concentrated HNO3. How much concentrated, that I will tell you in a next topic. Okay, I hope it is clear, student. If you cannot able to understand, you can ask me after watching this video. Got it? Okay. So now next one, that is next preparation, that is Oswald process. Oswald process, or we can say the large scale property, which means that in industry level, in industry, the Oswald process through the nitric acid will be produced. So the nitric acid, there are 3 steps. Okay, first step number 1, that is the oxidation of ammonia. The oxidation of ammonia first will take, so it's require ammonia, 1 volume of ammonia and 10 volume of the dry air. Why dry air? We want oxygen, we are doing oxidation, so we want oxygen. So the oxygen how to be impure free, so that's why dry air we are taking, so the very less or negligible amount of the impurity present in it. And why we are taking, why I told the 10 volume, which means we require more amount of the oxygen. So we are taking air, and in air number of things are present. So if we take a more amount of the air, then the more amount of the oxygen will be react with the ammonia. So the first reaction, that is, you need to remember this, the oxidation of ammonia, where we are taking 1 volume of the ammonia and 10 volume of the dry air. In presence of, this reaction is happening in a catalytic chamber. So in catalytic chamber, there is a platinum catalyst is used. So which catalyst? Platinum is used as a catalyst. So if we add a 1 ratio of the 1 volume of the ammonia, then 8 to 10 volume of the dry air we can use, or 10 ml, which means that 8 volume of the dry or oxygen is used. And in a catalytic chamber, in presence of, or 800 or around 750. In your textbook it is given 750. So the 750 degree centigrade temperature we need to apply, and through this both the thing is pass on through the platinum and it convert into the nitrogen monoxide, water, and the higher amount of the heat will be produced. The higher amount of the heat will be produced. That is the first reaction, and here this higher amount of the heat is producing, that's why this reaction is known as exothermic reaction. This is exothermic reaction. This is the balance reaction I wrote, but first I wrote this this reaction, normal reaction, that what required for this. So the in catalytical chamber first we'll take this oxidation reaction of the oxidation of the ammonia, and then oxidation of the ammonia in presence of oxygen will do, and then nitrogen monoxide will be produced here. So this is the balance reaction, that 4 volume of the ammonia plus 5 volume of oxygen, 5O2 in presence of platinum, 750 degree centigrade, it convert into the 4NO, which is in a vapor form, and the 6H2O plus 21.5 kilojoule, which means that is the kilocalorie will be produced, kilocalorie energy will be produced, or release, or heat we can say, heat will be released. That's why it is exothermic reaction, heat is releasing. So that is the first step. Now second step, when we take this nitrogen monoxide, so here the nitrogen monoxide will take into the oxidation chamber. So that now second step, that is the oxidation of NO. Second reaction, that is the oxidation of NO. So in oxidation of the NO, when the nitrogen monoxide react with the oxygen at 50 degree centigrade temperature, it convert into the nitrogen dioxide. Same reaction as I explained in the beginning of this chapter, the introduction. When the ammonia is react, is convert into the nitrogen dioxide, and it can make a nitrogen dioxide, NO2. So the oxidation of NO. Now the step number 3, in the step number 3, absorption of the NO2. Absorption of the NO2, which means that here the NO2 will be produced. Now the absorption of the NO2, when NO2 is passed through the hot water in presence of air, which means that we shower the water on this NO2 liquid, and then in presence of oxygen, so then nitric acid will be produced. So the nitric acid will be produced, and that nitric acid have a 68% concentrated HNO3, and we can increase the concentration. We can increase that concentration. How we can increase the concentration? We can increase that by adding more and more. This nitric acid will take in a first step. Here we can take one more time, we can take this nitric acid in this step, and one more time pass through this hot water, and one more time we will get our nitric acid, and slowly and gradually we will increase the concentration of the nitric acid. So here it is given in your textbook is that the octane of the nitric acid, here the octane nitric acid is very diluted, so it is recycle in absorption tower, so that more and more nitrogen dioxide get absorbed by the water. In this way, nitric acid after recycle become about 68% concentrated. Then we will get here, in order of the increase the concentration of the HNO3, the vapor of it are pass over concentrated H2SO4. So the concentrated H2SO4 is a dehydrating agent. Why? So when we are getting this 68% of concentrated H2SO4, then we will get we can increase the more concentration through this way also, and then through the more, if we require the more concentrated HNO3, then pass this nitric acid over the sulfuric acid. So the sulfuric acid is, as we know, that a drying agent. So what the sulfuric acid will do? Sulfuric acid will absorb the water from the nitric acid. Okay, and then water will be absorbed, then the concentration become more. So this is the way the high concentrated HNO3 we will get. I hope you understand this thing, student. you just read the both the topic, very important topic. This Oswald process asked in exam so many times, so many reaction asked about this Oswald process. So all these 3 steps you need to remember. So the step 1, step 2 and step 3, you just read all these 3 one more time, just take a screenshot if you want to remember this, and then you can read it. Got it? So here our preparation part of the nitric acid is over. In the next class I will explain you a physical and chemical property of the nitric acid and use that you will read yourself. Okay, I hope that I have explained you properly. Thank you.